Hello class, today we are going to talk about chords of circles. Alright, chords of circles, this is nothing like chords on a guitar or anything like that. Not talking music, that would be cooler, but we're not. So just to refresh, again, a circle, set of all points equidistant from the given point called the center. So circle P up there, because that's the center of the circle. A chord, again, is a segment with endpoints on the circle. So segment BC is a chord of the circle. Diameters are a special kind of chord that pass through the center. So again, BD, B is an endpoint on the circle, D is an endpoint on the circle, and it passes through the center. That's the diameter. It is a type of chord. All right, so a couple things about chords. Number one, the perpendicular bisector of any chord of a circle is the diameter of the circle. All right, so here we see this purple line is perpendicular to my blue chord, and it also bisects the blue chord, and you notice it goes through the center of the circle. All right, anytime you have a perpendicular bisector for a chord, it will go through the center of the circle because it's a diameter. Now, this also has some other things. All right, if your segment goes through the center of a circle and is perpendicular to a chord, that segment is also going to bisect the chord. So here, even though it doesn't show that it's bisecting the blue chord, it is. Also, if it bisects the blue chord and it goes through the center, it will be perpendicular. So because I know it bisects and it goes through the center, I know that these two segments are perpendicular to each other. Now, if the other chord does not go through the center, all bets are off. If it's not through the center, it may be perpendicular, but it's not going to bisect it because I've got it in the wrong spot, right? If it goes through this, let's see, give me another. Right. If, like this green one, this green chord bisects the blue chord, but it's not perpendicular, so again, it doesn't go through the center. All right. Basically, the way it works out is this. If you have two of the three, you're guaranteed to be the third one. If you have bisector and perpendicular, it's guaranteed to go through the center. If you go through the center and it's perpendicular, it's guaranteed to bisect. If it bisects and goes to the center, it's also guaranteed to be perpendicular. All right. So that's useful for some things. Back when Pokemon Go first came out, this is how I caught Pokemon. But then they changed it. And so now you got to do is go to the Pokestop. So anyways, archaeologists use this to find out, like say an archaeologist finds this broken piece of pottery and wants to know where the center of this dish would be or how big the plate would be, whatever it is they found, they can use it. They'll do this. They will trace the edge of their pottery, and then what you do is you draw two chords on their tracing, and then you find the perpendicular bisectors. So I am going to do that really quickly. I'm going to use constructions. Hopefully you remember how to do this. And just like that, by using perpendicular bisectors of two chords, we found where the center of this circle would be. And so then the archaeologist can measure this and find out how big the plate was. Right? So there's a couple of things you can do with it. Also, let's take a look at this. Point C is the center of the circle. We want to find the value of x. Okay, well, now if point C is the center of the circle, that means that this chord right here is the diameter. And notice it goes through the center, and it's perpendicular to this other chord, right? Which means it bisects this chord. So the question, this 2x plus 4, what is that going to equal? Is that going to be the same as the 8 over here or the 10 over there? Well, it bisects this chord here, right? And so that means it's the same as the 8. So 2x plus 4 equals 8. Subtract 4 from both sides, gives you 2x equals 4. Divide by 2, and x is 2. All right, not too bad. Next thing about chords. In a chord, we're in a circle. Two chords are congruent if and only if they are equidistant from the circle. So here, the pink segments are the same length, and notice it's perpendicular because distance is always perpendicular. So we have the same distance from the circle, and so segment AB is the same as segment DE. The two chords are congruent because they are the same distance from the center of the circle. All right. So let's take a look at this one. We find the value of x. Well, I don't know how long this chord is, right? But I do know, hey, look, pink chords are the same. That means the pink segments are the same. So we got the same distance from the center of the circle. That means my blue chords are the same length. So that means that this blue chord down here has a length of 16, and therefore x is going to be half that. Because again, the pink segment goes through the center of the circle, and it is perpendicular to the chord. Therefore, it bisects the chord, and so x is 8, half of 16, because these two chords are the same length because they are the same distance from the center of the circle. All right, next one, a little bit more complicated. If two chords intersect, then the products of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So what that says, let's do like this. Okay, AC times the length of CD is equal to the length of BC times the length of CE. So what that is, AC, the length of AC times the length of CD is equal to the length of CB times the length of CE. Okay, this is not a proportion. Not a proportion. Kind of similar, but no, not a proportion. Basically what it is, you take these two pieces of the one chord, you multiply them together, and they're going to equal the two pieces of the other chord multiplied together. That's it. All right, so let's take a look. We want to find the length of segment BD. BD is right here. We know the length of AE, EC, BE, and something about ED, x plus 1. So what we're going to do, we take these two segments and we multiply them together. So the 4 times the 3, because they're parts of the same chord, is going to equal 2 times x plus 1, because those are the parts of the other chord, both parts of the same chord. So 4 times 3 is equal to 2 times x plus 1. 4 times 3 is 12. Remember, we got to distribute, so we have 2x plus 2. Subtract the 2 from both sides. Gives you 10 equals 2x. Divide both sides by 2. And you get x equals 5. But doesn't ask us for x. It asks us for the length of BD. Well, let's see. X, that's part of ED, so let's go ahead and figure ED. ED would be 5 plus 1. Plug in the x in. All right, 5 in for x. So ED is 6. So BD is 2 plus 6. BE plus ED. And so BD is 8. All right. And that's pretty much it. So just to recap, if you have a chord, the perpendicular bisector of any chord is going to go through the center of the circle. All right? And if it goes through the center of the circle and it's perpendicular to the chord, it will also bisect the chord. If it goes to the center of the circle and it bisects the chord, it will also be perpendicular. All right? Also, two chords are congruent if and only if they are the same distance from the center of the circle. And so if these two are congruent, if AB is congruent to DE, then you know that these two distances are the same. And lastly, if two chords intersect, then the product of the segments of one chord is equal to the product of the segments of the other chord. So this piece times that piece is going to equal this piece times this piece. Okay? Don't go like this. All right? Don't mix the chords up. You got to multiply the pieces from the same chord together. All right, so AC times CD, not AC times CB. That'll mess you up. Blue times blue, red times red. Okay? All right. Hope you found that useful, and I will see you in the next video.